So here's our week 8 summary. This week we kind of finish up with going over the color table and kind of color frequencies. And then we got more involved as far as how our telescope is going to be affected. As far as calculating the focus, getting our distance of the object, distance of the image, and also the height of the object. We were able to do this using certain calculations and certain formulas. We could predict exactly based on a certain height and distance, we could predict we come in through a certain focus where our image would end up projecting on the other side. So we had to also trace that out in diagrams to show our focal point, how once that image comes in, so our distance of the object, how our distance of image is affected. So we traced that and it showed how the rays would come in through a certain point and then they will also go back out. So it was a lot of notes this week as far as his calculations, and this is the type of stuff that's going to help us to be able to build our telescope. So that was fun to learn. We had to also do the ray inside of the focal point. So actually we start at a focal point and we had to show how the rays would go outward. And by doing that, it showed that once you start at that certain focal point, our rays would go out a certain way. They would never meet out. They would kind of go out to infinity. So that was a lot of the class focus this week. And also with our group, we picked the U of A Mirror Lab as our research project. So we got to go down there Friday. And this was very interesting. I mean, it went through all the different type of lenses that they're working on right now. They're working on a lens from Mexico, the LSST lens. They were working on that. And that lens is expected to be ready in 2022. And they started this project in the 90s. So we got to get a one-on-one with Philip Pinto. So he kind of explained, the rationale behind this, why they wanted to make the LST and that different type of information there. So basically right now it's in the polishing stage with the actual mirror lens. And so it's actually getting it smoothed out, getting it all ready to go. And basically I was asking him about the government shutdown, how is that going to affect the projected date of this to be finished. And he basically said that if I wrote him a check for $486 million right now, then they would be on target. But they need to get this money secured by July of 2014. He said every month that goes past that they don't get the money secure, that extends out their date of when this LSST telescope is actually going to be available and be ready to go. So, I mean, it's a lot of red tape. They pretty much got all the mechanics of how they wanted to operate. But their biggest thing right now is money, getting commitments, and going through all the government red tape. So, I mean, so we went through everything as far as how the cone is made to actually where they melt the glass onto the for the telescope lens, to how it's cooled, how it's heated, and it's also a picture of how it kind of looks once it gets situated, and how they have to smoothen and polish it for it to be a perfect parabola. That way they're able to get all the focal points that they want. And he said with this LSST lens, once this gets completed, he pretty much said they'll be able to see to like infinity. He said it will be so sharp that they can focus on a cigarette if it was on the moon. So, I mean, it was just really exciting to learn about that. So basically this week in physics, I would say spent probably about, I don't know, 20, maybe 10 or 14 hours on this. As far as week 8, just because I'm still doing a lot of research as far as getting my controversial topic together. And mine is on vaccines, and there's a lot of information out there. Trying to figure out how our group is going to do our research project. and also just going down to the mirror lab. So me, Andy, and Alicia went down, and it was um, a couple more people from the school that actually went with us. And we had a nice group. It was probably about, I don't know, 15 or 16 people with the whole group. And our, guy gave us our presentation, and we walked around, and we got to see the scientists, the super smart people. It was one guy there who had like a PhD in physics, a PhD in something else, and this guy was like 35 years old. He had like 3 or 4 degrees, so he was like super smart. But it just shows how you have to have all these people, not only the people that's the astronomers and that thing, you got to have the engineers, because the astronomers pretty much come up with the design and how they feel about, how they want the mechanics and everything of this to work. Like they come up with a general design. And then they get the engineers to kind of perfect their design. So, I mean, if you want an 8.4-meter telescope, the only place you can get this done is at the U of A Mirror Lab. So they are the only ones kind of doing this in the whole world. And that was really interesting to see. So that's week 8 summary.